Hi there. This video is an exam paper walkthrough of the Edexcel GCSE Mathematics Higher Tier Paper 3 from summer 2023. This paper is worth 80 marks in total, and this is the fourth video of 4. It will focus on questions 20 to 24, which account for 19 of these marks. Edexcel Paper 3s are calculator papers, so a calculator should be used. A little disclaimer, there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 20. Prove algebraically that 0.123 recurring can be written as 61 over 495. So we're going to write this as an algebraic fraction, and what's really important to note here is that the recurring signs are only over the 2 and 3. So this value, 0.123 recurring, is technically 0.1232323, and it would keep going repeating the 2, 3. Okay, so I'm going to do two different versions of this now. Because I've got 3 digits here, I'm going to do 1000x. If I multiply this by 1000, I get 123.2323 recurring. And then I'm also going to do 10x, because that will give me 1.2323 recurring. And then now what you'll notice is the recurring values after my decimal point match exactly. So now I'm going to subtract these two versions from each other. So 1000x subtract 10x is equal to 123.23 subtract 1.232323. Well, when I subtract them, the decimal part's going to cancel out. So I'm doing 123 subtract 1. So 1000x subtract 10x is 990x, and 123 subtract 1 is 122. So x is equal to 122 divided by 990. Now I need to show algebraically that it can be written as this. Well, if I half 122, I get 61. So if I half 990, I get 495. So I've shown that that recurring decimal can be written as that fraction. Question 21. So we're going to solve this equation that has algebraic fractions. Okay, so what I want to happen is I want to eliminate these fractions on this side. So to eliminate these fractions, I need to multiply by x plus 4, and I need to multiply by 2 minus 2x. Now this is where you need to be careful. When I multiply by x plus 4, that's going to multiply the numerator of this fraction and the right hand side of the equation. Okay, so that would leave me with 1 plus 3x plus 4 over 2 minus 2x equals 1 times x plus 4. And then when I multiply by 2 subtract 2x, I've got to multiply this term. It will cancel out the denominator here, and then I need to multiply on the right hand side. So multiplying by 2 subtract 2x gives me 1, 2 subtract 2x plus 3x plus 4 plus 1 times x plus 4 times 2 minus 2x. So now it's a case of expanding and simplifying. So this 1 times just leaves us with that. 3 times x is 3x, 3 times 4 is 12. 1 times leaves us with that, so x times 2 is 2x. X times negative 2x is negative 2x squared. 4 times 2 is positive 8, and 4 times negative 2x is negative 8x. Now I'm going to gather everything to the left-hand side, and the reason why I'm gathering everything to the left-hand side is because I don't want a negative x squared term. Okay, so let's just simplify a little first. So we've got 2 plus 12 is 14. Negative 2x add 3x is x. So the left-hand side simplifies to x, add 14. The right-hand side simplifies to negative 2x squared. 2x subtract 8x is negative 6x plus 8. So I'm going to add 2x squared to this side. I'm going to add 6x to both sides. And then I'm going to subtract 8 from both sides because I need a quadratic to be equal to 0 to be able to solve it. So now I'm going to attempt to factorise. So that would be 2x and x. Two numbers that multiply to give me 6. 1 and 6, 2 and 3. Add to give me 7, but one of them is going to get multiplied by 2. So it's going to be this pair that I use. So it'll be plus 2 and plus 3 is equal to 0. So for this bracket equal to 0, 2x is equal to negative 3. So x is equal to negative 3 over 2. If the right-hand bracket is equal to 0, x is equal to negative 2. So we've got two solutions here. X equals negative 3 over 2 and x equals negative 2. Question 22. Given that the vector A plus the vector B is parallel to this vector, find an expression for B in terms of A. Okay, so if the sum of these two vectors is parallel to this vector, then they must be equal to a multiple of that vector. Okay, for them to be parallel, they've got to be a multiple of each other. Okay, so from this, I can read that actually 2a plus 8b must be equal to 13k, and 6a plus 2b is equal to 6k. In fact, we don't need the k's there. So I've got two simultaneous equations here, guys, that I can work with to solve. So let's make our b's the same. So let's times this one by 4. So I've got 2a plus 8b equals 13. And 24a plus 8b is equal to 24. Now I'm going to subtract these equations to eliminate the 8b because they're both positive. Okay, so 24a subtract 2a is 22a. 24 subtract 13 is 11. These have cancelled out, so a must be equal to 11 over 22, which is 0.5. I'm going to substitute that in to find b. So if a is 0.5, so 2 times 0.5 is 1. So 8b is equal to 12. So b is equal to 12 over 8 or 3 over 2. So a is 0.5, b is 3 over 2. Okay. So, if b is 3 over 2, this is 1.5. 1.5 is 3 times 0.5. So an expression for b in terms of a is b is equal to 3 times a. So b is equal to 3 times a. Question 23. A circle has equation x squared add y squared equals 25. The point P with coordinates negative 3, 4 lies on the circle. Alex says that the tangent to the circle at P crosses the x-axis at the point negative 8, 0. Is Alex correct? You must show how you get your answer. Okay, so we're dealing with a tangent to a circle. We've got point P, which is a negative 3, 4 coordinate, and we've got this circle here. Now this circle must have a centre of 0, 0 because of how it's written with the x squared add y squared. And the radius is the square root of 25, which is 5. Okay, so the first thing we're going to do is find the gradient of the line or the gradient of the radius. So if we imagine we've got this circle, this is our centre 0, 0. Point P is negative 3, 4, which would be, say here, if that's negative 3 and that's 4. So we're finding the gradient of this line here, okay? So we're going from 4 to 0. That's a change in y. And then from -3 to 0 is a change in x. Okay, so we have a -4/3 gradient. Okay, because we have a -4/3 gradient, if we're finding the equation of the tangent at the circle, which we're going to have to find to see if this point is where it crosses the x-axis, okay, we need the perpendicular gradient. So the gradient of the tangent is the negative reciprocal, so it would be 3/4. So y equals 3/4x plus c would be the equation of the tangent. We know that the tangent is at the point P. So when x equals -3 and y equals 4, 4 equals 3/4 times -3 plus c. So 4 equals -9/4 plus c. So c equals 4 plus 9/4. Do that in your calculator, guys. 4 plus 9/4 is 6.25. So the equation of the tangent is y equals 3/4 x plus 6.25. Now, what we need to do is decide whether or not the tangent to the circle at this point crosses the x-axis at -8, 0. So when y is 0, what does x equal? So when y equals 0, so 0 equals 3/4 x plus 6.25. So 3/4 x equals -6.25. So x equals -6.25 divided by 3/4. So x equals -6.25 divided by 3/4. What did I do? Put an extra negative on. Equals -8.3 recurring. So Alex is not correct. Because it crosses at -8.3 recurring, not -8. And we've shown all of that there with our working. Question 24. There's a total of y counters in a box. There are x pink counters and 5 blue counters in the box. The rest of the counters are green. So we've got pink, blue and green counters. The ratio of x to y, so the number of pink counters to the total counters, is 1 to 3. Frida takes at random 2 counters from the box. Find in terms of x an expression for the probability that Frida takes 2 counters of the same colour. Give your answer as a fraction in this form where a, b, c, d and e are integers. So integers means we want whole numbers where those letters are. So first things first. Here, if we look, it's all in terms of x. But we know that the total number of counters in the box is y. So I'm going to need to, at some point, express y in terms of x. And I can do that from here. Because if y is 3 and x is 1, then y is 3 lots of x. And we're going to use that later. We're going to park it here, but we're going to use that later. Now we need to look at these probabilities. So we want the probability that Frida takes 2 counters of the same colour. So we're looking for the probability that she takes pink and pink, probability that she takes blue, and the probability that she takes green and green. Okay, so probability of pink then. So the first time she picks a pink counter, we've got x possible outcomes out of y in total. The second time she picks pink, we've got 1 less pink and 1 less in total. So our probability of picking pink and then pink is x squared minus x over y squared minus y. I've multiplied the numerators and the denominators. Let's do the same with blue. So there are 5 blue counters. So the first time Frida picks a blue, it would be 5 out of y. Remember, y is the total number of counters. The second time Frida picks blue, there's 1 less blue to pick from, so that's 4, and then there's 1 less counter in total, so that's y subtract 1 again as the denominator. So 5 times 4 is 20 over the same denominator. And we'd expect this with probability. Okay, probability of green and then green. So the probability of picking the first green will be the total number of counters. Take away how many pink and how many green. So subtract X and subtract 5 out of the total. Then there would be one less green to pick from. So it would be the total subtract X subtract 6. That's one less over Y minus 1. So when we simplify this one, it's a little bit trickier. So I'm going to put these guys in terms of X fully. So if I add these two probabilities, I've got X squared minus X plus 20 over this Y squared minus Y. But I'm going to do it as this, look. 3x squared minus 3x. Remember, there was a reason why we needed it writing in terms of X. Plus this thing here. Okay, so Y times Y. That's where it gets a little bit complicated. So Y times Y is going to give us Y squared. Y times minus X. In fact, let me make this even easier. Y is 3x. Remember that. So we're going to substitute with that with 3x. Substitute that with 3x. So 3x subtract x is 2x minus 5. So you've got 2x minus 5 and then you've got 2x minus 6. All going to be over this same denominator here. Okay? So now let's simplify this a little bit further. So we have x squared subtract x plus 20 over 9x squared subtract 3x plus 2x times 2x is 4x squared. 2x times minus 6 is minus 12x. Minus 5 times 2x is minus 10x. And minus 5 times minus 6 is 30. And it's all over that same denominator. So I'm not going to write it again. I'm just going to simplify it even further. So x squared plus 4x, 5x squared. Negative x, take away 12x is negative 13x. Take away 10x is negative 23x. 20 plus 30 is 50. All over 9x squared minus 3x. Okay, so we have x squared, x and a constant. X squared, x and a constant. And then we have an x squared and an x squared and an x. So let's just make that nice and clear on our answer line. There we go.